Okay, so welcome to our last set of notes for the year. Chapter 26. This is Inference for Linear Regression. So remember we've done linear regression before. That's our slope-intercept, best fit. We would look at scatter plots. And so this is when we're going to be comparing two variables and looking at a scatter plot. So these are our scatter plots. And what we're doing is we're actually going to be trying to make inferences on the slope. Okay, so what this is called the regression slope t-test. So slopes is a t-test. Sorry for that being sloppy. Okay, so there's 4 different conditions we have to know. The first condition is that is it straight enough? And these actually conditions we've already talked about when we go back and you look at, I think it was chapter 6 and 7. So for this one, you have to look at scatter plot and residual plot. We haven't done that in a while, so we will practice that in class. So look at scatter plot and residual plot. And do you guys remember what residual plot's supposed to look like? Remember, it's supposed to be random. You're not supposed to see a curve. It's supposed to be random points above and below the x-axis. Okay, so for the independence / randomization, so the independence is that the values independent of each other. And then randomization, you can kind of think about it as the residual plot random. My handwriting is a little bad today. Sorry about this, guys. Okay, so then the next one we talked about, the technical term is the equal variance. That's the, does the plot thicken? And remember what's supposed to happen is that points are equally spread around the best fit line. And then the normal population, this is the one that's new. And what you'd have to do is you have to look, does residuals, so do the residuals, I should have said do the, not does, do the residuals fit a normal model? And so what we have to do is we have to look at a histogram of residuals. And remember, we used to get our calculator to do this. And so remember, our residual formula is observed, oops, not OPS, observed minus predicted. Okay, so that's our formula for residuals. It's observed minus predicted. Okay. So the formula is down here. You're going to use some, but really not that often. This is the standard deviation. Usually what's going to happen is we're going to actually get everything from printouts or a calculator. You're not going to be doing anything by hand. But so there's 2 different things. Remember, SE is the standard deviation for residuals. And then the standard error for the slope, it's going to have a B here, or sometimes it's going to have it like beta, like this. Okay. All right. When we find our degrees of freedom for this, because we have an X variable and a Y variable, there's 2 different variables. We're going to do N minus 2. So degrees of freedom for linear regression is N minus 2. Oops, when we write our hypothesis and our Ho value, it's always going to be the same, okay? Your hypothesis is that there is no association, because remember, linear regression looks for association, so no association between the 2 variables. And the symbol you use for this is the slope is equal to 0, because no association would mean there's no slope, okay? And then the other one is there is an association. You're going to see some that are greater than or less than, but not many. Most of them are going to be just is an association. And again, I apologize for this horrible handwriting. Okay. All right. So let's recap this real quick. So scatter, this is when we're looking for regressions. It's called the regression t-test. So it's the slope t-test. We have these different conditions. Is it straight enough? When we look at our residual plot, are variables independent? Are they equally spread out? And then the new one again is this: does residual plot fit the normal model? And then here are your different formulas. You're not going to ever have to do them by hand. You're going to get them from computer printouts or the calculator. To find degrees of freedom, it's n-2, and it's n-2 because there's two variables. There's an x variable and a y variable. Your ho and your ha is there's no association between the variables, and then there is an association. And again, this kind of Roman numeral capital B is for slope. So no association is 0. There is an association is not equal to 0. Okay, that's how most of them work. All right, the ones that I'm going to help you with today is just our printout. I'm not going to do calculator ones today. We'll do calculator ones in class. And so for each of these, we're going to write an equation. We're going to determine the t-value, and we're going to determine the p-value. So we've actually done these before. So you can see right here, this is not equal, so it's two-tailed. And so remember that this is our y-intercept. It either says constant or intercept. And then this one is our slope. And we focus on these coefficients because those are the numbers that represent our y-intercept and represent our slope. Okay, it says the dependent variable right here, you see this, is no opinion. So we are predicting no opinion. So remember when we make up predictions, we put a hat on it. So no opinion equals our y-intercept, 7.69262, plus our slope, but our slope is a negative, so I'm just going to do the minus 0.042708. And remember, you have to write the word, and the word is year. So that's not new, it's just something we haven't seen in a while. Okay, the next thing is the t-value. So the t-value is the t-score, how far away it is, or it's the z-score. Let's see, t-value. Okay, so to find the t-value, we're going to have to do this. And remember, it's your value minus the mean divided by the standard error. So we are finding the t-value for slope. And so our slope is this right here, negative 0.042708. And it's minus our hypothesis value, that's the mean, which is 0. And then you divide it by the SE of slope, which is right here. Now, I know that we don't have to divide by 0, but I want us to remember this formula. And so some people will need to have that formula, and they just have to go find it each time, and this time it's 0. And for all of these problems, it's going to be 0. And so your t-value is going to be negative 1.21. So that's negative 1.21 tick marks away, which isn't super big. It's not too far away. And so now what we're going to do is we're going to take our calculator. And so our value is 0. This is negative 1.21. Now here's the thing. Remember, it's two-tailed. So whatever I get for my answer, I'm going to have to double. And so this is a t, so we're going to use TCDF. Okay, let me go get my calculator. Okay, so I found my calculator. Again, it's a t, so we're doing TCDF. So second distribution. Here's TCDF. The lower, we don't really know. It's really on the left, so that's a good number. The upper is negative 1.21. And my degrees of freedom, okay, well, let's see. Remember, your degrees of freedom is your sample size minus 2. And look, it actually tells you right here. You see that? It tells us our degrees of freedom. So our degrees of freedom is 14. Hold on, where to go? So 14. And so our p-value is 0.12, keeps going away, 0.123, but that's only for one side. And since it's not equal to, it's two-tailed, so I need to times that by 2. So it's 0.246. And so with that, we would know that we would fail to reject. There is no evidence that there is an association between what is it? Between year and the opinion. Okay. A lot of computer printouts will actually have the t-value score there and the p-value. But today these don't, and so I want to make sure you understand how to find them. These are worst case scenarios. Okay, so what I would like you to do is I would like you to try and stop the video, and I would like you to see if you can write your equation, calculate your t-value, and find your p-value. And once you think you have it, go ahead and press play. Okay, so right here you should see it's men minus women. It's kind of a weird thing, but that's what it says right here. It says men minus women. And so the predicted difference between men and women is this equation. 49.9021 minus 0.023957 times year. To do the t-value, again, we always focus on slope. The slope is the most important thing. So we do our value minus the mean, and our mean is always 0 for slope. We're always assuming it's 0. And then divided by the standard error. This is 4 tick marks away. That's pretty small. And so again, second, let's do this one more time so you remember. Second distribution, TCDF. So second distribution, TCDF. And this time my upper is negative 4.36. It says my degrees of freedom is 22. And so that's how I got my p-value. And this is a pretty small p-value, so with a small p-value, we failed to reject, or we reject the null. There is evidence that the difference in men and women, there is an association between the difference of men and women in year. Now, if you're wondering why I didn't double because this is a one-tailed. So I don't double on a one-tail, it just says less. All right, so remember you have to check your conditions. We will practice in class finding out how to find out if our residuals are normal. Right now, the main thing you need to do is kind of understand how to read the table and to find answers from the table.